Today we're going to talk about Taylor polynomials. And a Taylor polynomial is something that's pretty cool. If you look at just this part of the Taylor polynomial, this should look familiar to you because it's just the equation of the tangent line that we've been using all year, just written in a little bit different way. Recall that the equation of the tangent line is y equals m times x minus x1 plus y1. Well, could I write that as, what's m? Well, that's f prime of some value, let's call it a, times x minus, well, if a is x, plus f of a. Isn't that f of x right there? That's just this, okay, over 1 factorial. I can extend that and make not just a tangent line, but like a tangent parabola and a tangent cubic and a tangent all the way up as far as I want to go. This is a little program that shows the Taylor polynomial. This is the Taylor polynomial with degree 1. It's a tangent line at a, some point a. And this looks like the sine graph. Okay, watch what happens when I go out. There's the Taylor parabola. See it? It models more closely the curve just at a farther away from, it's kind of like from here to here. Converges on the curve. Watch what happens when I go to 3, 4, 5, 6, 7, 8, and so on and so forth. The farther out that I go with my Taylor polynomial, the more closely it models my curve, to where at this point it's almost matching the entire curve that I have in this particular window. Now if I zoom out, obviously it's not going to match it as far. And what happens is the more terms you get, the tighter the interval of convergence is. In other words, it converges onto the curve. Let me see if I can get it back in. The interval, like what's called the interval of convergence, right here, this is the tangent line. It only converges at that one point. It only matches the curve if you're at a. The farther away from a you get, the farther away from the actual value you are. Well, if with the parabola, the interval is closer. It matches the curve for a wider space on the graph. In this one, it goes from here to here, and so on. Okay, and to make a Taylor polynomial, what we're going to do is we're going to create Taylor polynomials to match various common functions. And these are the ones that AP actually expects you to have memorized here. Don't worry about memorizing them just yet. We're actually going to look at how to get them first. It says compute the Taylor series for f of x equals cosine of x about x equals 0. And I'm going to first begin by writing my equation. Well, they call it t, and I'm just going to go to the third degree. I'm just going to tell you. That's how far I want to go. Usually they will tell you. And they call it t sub 3, okay, equals f of x plus f prime of x times, I need to be using a's here. X isn't going to work for me because this is at some value a. F prime of a times x minus a over 1 factorial plus f double prime of a times x minus a squared over 2 factorial plus f triple prime of a times x minus a cubed over 3 factorial. If you wanted to go to the fourth degree, it would be f fourth prime of a times x minus a to the fourth over 4 factorial, and so on and so forth, forever and ever. So the easiest thing I'm going to do is I'm just going to come down here and I'm going to say that my f of x, I'm going to just come up with all these things as cosine of x. Well, I'm going to go ahead and just take some derivatives. My first derivative of cosine is negative sine. Second derivative is negative cosine. My third derivative is sine. And if I wanted to go to the fourth, I could. I'm not going to though, because I only need to go to 3. You can go as far as you want to go. And then I'm going to go ahead and find these values because I'm going to need to fill them in. At 0. So I'm going to find f of 0. I'm going to find f prime of 0, f double prime of 0, and f triple prime of 0. Well, f of 0, cosine of 0 is 1. F prime of 0, sine of 0 is 0. Negative cosine would be negative 1. Triple prime would be sine of 0 is 0. And now I'm just going to fill them into my formula. F of a, and everywhere there's an a, I'm using a 0. So essentially that's a 0, a 0, a 0, a 0, a 0, a 0, and a 0. Okay, so f of 0 is 1 plus f prime of 0 is 0 times x minus 0 over 1. Okay, so that one's actually going to go away. And I know why I wanted to go to the fourth term, because we're going to go ahead and go back and grab 4. That's triple prime. Just to get us one more term, because some of these fall away, and that'll be a positive 1. Okay, so, oh, my nose is itching. Okay, f double prime is negative 1 times x minus 0 squared over 2 factorial, plus f triple prime is 0 times x cubed over 3 factorial, plus the next one would be f4, 1 x to the 4th over 4 factorial, plus dot 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 dot. Clean it up a little bit. This one's gone, this one's gone. So it's 1 minus 1x squared over 2 factorial is 2, plus this one's gone. 1 over 4 factorial is 4 times 3 times 2 times 1. Let's just leave it 4 factorial. I'm good with that. Okay, and if you actually wanted to write an equation for the nth term, plus dot dot dot, notice these alternate. That's a positive 1, a negative 1, a positive 1. The next one would be negative 1. You could actually go ahead and probably predict what these would be if you continued on. I'm not going to. Negative 1 to the n, x to the 2n over 2n factorial. I will explain that in class, how I got that right there.